Okay, in this video, we're going to talk about how to solve systems of equations using the method of substitution. So let's look at this example. The goal when using substitution to solve a system of equations is that you're going to need one variable, any variable, x, y, or if we're using different variables, any one of them by itself. I need to get one variable by itself. Okay, if we just look at this equation, there's no variables alone here, but in this equation, I actually already have y by itself. So y is equal to 5x plus 1. They're equivalent, which means I can plug 5x plus 1 anywhere I see y in my other equation. So I'm going to plug it in right there. And what that's going to look like is 2x minus 3, and then instead of y there, I'm going to put what y is equal to, which is 5x plus 1. I got to remember to bring everything else down equals 10. And now I'm just going to go about solving this. Negative 3 times 5 is negative 15x. Negative 3 times 1 is negative 3 equals 10. When I put these like terms together, I get negative 13x. I'm going to bring down my minus 3 equals 10. I need to move the 3 to the other side. And I get negative 13x equals 13. I want to get x by itself, so I'm going to divide by negative 13. And so finally, x is equal to negative 1. That's great. We know what x is equal. But when we have a systems of equations, we have to know what x and y is equal to. We have to know both variables. So I'm actually going to use the fact that x is equal to negative 1 to solve for y. If x is equal to negative 1, I can plug in negative 1 anywhere there's an x in either equation. So you could choose to do it here, but I'm going to do it here because y is already by itself, and that's going to make me have less steps. So y is equal to 5x plus 1. When I plug in the negative 1 for x, I'm going to put parentheses and I'm going to plug in negative 1 right where x is, plus 1. And then we're just going to solve this. So 5 times negative 1 is negative 5, plus 1 is negative 4. So now I know x and y, which was the goal. But I always want you to write this as a coordinate pair. So x comes first, that was negative 1, and then y was negative 4. This would be my answer. Guys, these are the points that work for both equations. They make both equations true. This is the point of intersection if we were looking at a graph for these two equations. Okay, let's look at the next example. Remember, we need to have a variable by itself. And if we look at these two equations, in both of these, there's no variable by itself. So you get to pick. Do you want to solve for x and y, or y? And do you want to do it in this equation or this equation? It doesn't really matter. But if you take a moment to look at the equations, you might be able to make your life a little bit easier. For example, if I chose to get the x by itself, I would be dividing everything by 8. 3 divided by 8 and 6 divided by 8, those are going to give me fractions. And then I have to work with fractions. And that's okay. And a lot of times you're going to have to do that anyway. But let's see if there's another option. If I choose to get this x by itself, that means ultimately at some point I'm going to be dividing everything on this equation by 2. Well, 6 divided by 2 is a whole number, and 12 divided by 2 is a whole number. So we don't have to worry about the fractions here. So I'm going to use this equation, and I'm going to get x by itself. By doing that, I'm going to move the 6y first, and I'm going to get 2x equals 12 plus 6y. And then I have to divide every single term by 2 to get x by itself. So x is equal to 6 plus 3y. 12 divided by 2 is 6, and 6 divided by 2 is 3. We have the y there. So x is equivalent to 6 plus 3y, which means I can plug this in anywhere I see x in the other equation, which is right there. So 3y plus 6 equals 8. And instead of that x right there, I'm going to put parentheses, and I'm going to plug in what we know that x is equal to, which was 6 plus 3y. And now we're just going to solve. And we should all know how to do that by now. I'm going to distribute the 8 first. So 6 times 8 is 48. And 8 times 3 is 24y. I now need to get these two y's by itself. You can move either one, but I'm going to move the 3y by subtraction. And I get 6 equals 48. 24 minus 3 is going to give me a 21y. And finally, I need to get the 48 over here. It's positive, I'm subtracting. 6 minus 48 is going to give me a negative 42 equals 21y. And to get y by itself, I'm dividing by 21. So negative 42 divided by 21 is negative 2 equals y. Okay, so now I know what y equals, and that's great, but remember we do have to solve for x. I can plug this -2 into any y that I see. So I could do it here and solve this equation for x, or I could do it here. But since we already have x by itself here, it's going to make more sense for me to do it here. I just have less steps. So I'm going to take my x equals 6 plus 3y, and I'm going to plug in the -2 into y here. So x equals 6 plus 3 times -2. So x equals 3 times -2 is -6, and I have a positive 6 here, so that's going to make 0. So my x coordinate is 0. When I write this as a coordinate pair, make sure you put x first. We solved for y first, so sometimes people accidentally write the -2 first, but we have to make sure we put the x value first. So 0, -2. And that is the solution to my systems of equations. Okay, let's look at this example. So this example I have on here for a very specific reason. Okay, but we're going to start it the same way. We need to get a variable by itself. I can see that this x is almost by itself there. There's actually a -1 in front of that, so I'm going to have to deal with that, but I'm going to use this equation. So I'm going to take my 3y minus x, or 1x, equals 5. And I'm going to get x by itself. I'm going to subtract the 3y from both sides. So I get -1x equals 5 minus 3y. Now, if I hadn't put the 1 there, I would have a -x. You can't forget about that negative. You have to divide by a negative on every term, which sometimes it's easier to just put the 1 there, then you don't forget that. So I have x equals 5 divided by -1 is -5. -3 divided by -1 is +3, and then I have the y there. So x is equal to -5 plus 3y, which can go into my x value. I'm going to have to take this, and we're going to go over here because this is the equation we didn't use. So that's going to be -4, and then in parentheses, I'm going to have the -5 plus 3y. I have to remember to write everything else down. So I have plus 12y equals 20. So let's start solving this. -4 times -5 is 20. -4 times 3y is -12y. And then I have to bring down this 12y and this 20. When I go to combine these like terms, look what happens. -12 plus 12 is 0y. We don't want to write 0y, we just want to get rid of it. So it's not there anymore. So I have 20 equals 20. Now this is a true statement. 20 is equal to 20. So that's good for us. But when this happens and we don't have the variable anymore and we just have a true statement, we say there are infinitely many solutions. Okay, and what that actually means is that these are the same line. So they're just different forms of the same lines, but it's one line lying on top of the other line, and all coordinates will match up. Okay? All right, we have one more example, again, for a very specific reason. So we're going to start the process the same way. I need to solve for a variable. You can pick which variable you want to solve for. I'm going to choose this x right here because I do know that it's going to make life easier, and I'm just not going to have to deal with the fractions today. But again, fractions are okay, and many times in class, you're just going to have to work with them. I want this x by itself. I'm going to move the 10y. So -2x equals 2 minus 10y. Divide everything by -2. And I get x equals -1. -10 divided by -2 is a positive 5y. So x is equal to all of this, which can then be plugged into the x in my other equation. So 3 plus 25y equals 5, and then I need to plug in the -1 plus 5y, since that's equivalent to my x here. Okay, let's start solving. So 5 times -1 is -5. 5 times 5 is 25y. Okay, our next step would be to get my y terms together. So I need to move one of these to the other side. It doesn't matter which one you move, but this is positive, so I'm subtracting. And look what happens again. 25 minus 25 is 0, so this goes away. So the only thing that's left in my equation here is 3 equals -5. And that is not a true statement. That is false. 3 will never equal -5. When that happens, we write that there is no solution. These lines will never intersect. They do not have a set of coordinates that work and satisfy both equations. So when this happens, you just write no solution. And remember, if it's the same value and your y's or your variables have gone away, then we put infinitely many solutions. Okay, I hope that helps with the systems of equations, and I will see you in the next video.